Section 7.7 is about operations with functions. This key concept gives us a bunch of operations that we can perform with functions. For instance, we can add two functions together, subtract them, multiply them, and divide them. Here you see some examples of how to do that, and we'll be doing a lot of examples in this section to practice. One thing to note down here is that the domain of the new function is the intersection of the two previous functions. In other words, the domain of the new function is where the two old functions overlap, what they both have in common. That's what the word intersection means. Also, when you divide functions, that's what quotient means, you need to watch out for excluded values, values that make the denominator equal to 0. So here we'll practice adding and subtracting these two functions. When you have f plus g of x, that's the same as saying f of x plus g of x. So we'll take the f of x function, and to that we'll add the g of x function. Now because you're adding everything, we can drop the parentheses and then just collect like terms. X squared is going to go first, and then we'll have negative 3x plus 4x is positive x, and 1 plus 5 is 6. Over here, f minus g of x, according to our key concept, is the same as saying f of x minus g of x. So again, we'll write them out, but this time we'll subtract. So now I can drop the first set of parentheses, but because we have a negative in front of this one, that's like a negative 1 that has to be distributed. So this becomes minus 4x minus 5. So now we'll collect like terms starting with the x squared. Negative 3x minus 4x is negative 7x. And then 1 minus 5 is negative 4. So here are two more functions that we will multiply and divide. So f times g of x is the same as taking f of x and multiplying it times g of x. So we'll write that out. So here we use the distributive property. X squared times 3x is 3x cubed. X squared times negative 2. Distribute the 5x, we'll get a positive 15x squared and a minus 10x. Then we'll distribute the negative 1, negative 3x plus 2. Collecting like terms, start with the 3x cubed. We will collect the negative 2x squareds and the 15x squareds to be a positive 13x squareds, and then minus 10x minus 3x minus 13x, and then plus 2. Over here, f divided by g of x is the same as f of x divided by g of x. Now there isn't a whole lot I can do with this division of two polynomials. I can look at the bottom because I need to find any excluded values that would create a 0 on the bottom. And so if I take the denominator and I set it equal to 0 and then solve it, I'm going to get 3x equals 2, divide by 3. So we can find out that if x equals 2/3, that'll create a 0 in the denominator. So we call that an excluded value. So we say that x cannot equal 2/3, and that has to be included whenever you do division. Now we'll learn about a composition of functions. Let's say you have two functions, calling them f and g. Let's say the second one has a range that fits into the domain of the first one. Then you can find the composition of the functions. And this little symbol, this tiny little O, is used to represent composition. And the composition of functions is no more than just taking the inside function first, getting a value, and then taking that value inside of the first function, or the outside function. Now it is possible for those two functions to not have a composition. It might not exist because perhaps the range of the inside function does not fit in the domain of the outside function. Here we have an example of a composition of functions. We first want to find f of g. So we're looking for f of g of x, which means we do the g first. So in the g function we have 4 points. So we'll ask ourselves, what is g of 5 first? And then we'll take the f function of that. Well, g of 5, if you look over here, when you plug a 5 in for the domain, you get a 7 for the range. So we're actually going to find f of 7 now, because that's what g of 5 is. G of 5 is 7. And then go to the f function. You see a 7 for the domain, and then you get an 8 for the range. So the composition with the number 5 gives us an 8. And we do that with all of these. We now want to find f of g of 3, because 3 is the next value in the domain. So 3 gives us a 5. So now we want to find f of 5, and f of 5 is 3. So now find f of g of 7. 7 for the domain gives us a 9 for the range. So now we find f of 9, and 9 gives us an 8. Last one, g of 9. 9 for the domain gives us an 11 for the range. And an 11 for the domain in the f function gives us a 4 for the range in the g. So then our final answer is f composition g, 5, 8, because we plugged a 5 in, got an 8, 3, 3, 7, 8, and 9, 4. Now we're going to do the other composition, g of f. So that means we do the f of x first, and then take that range value, plug it in for the domain of the g, and then find that value. So f of 7 is an 8, and 8 in the domain of the g function does not exist. So we're looking for g of 8 now, which is not there, so we say that g of 8 is undefined. Next one, plug a 5 in for the f function, get a 3. So we're looking for g of 3. G of 3 is a 5. F of 9 gives us an 8, so we want to find g of 8. And g of 8 does not exist again, so that's also undefined. Last one is f of 11 gives us a 4, so we want to find g of 4. 4 is not in the domain of the g function, so our last one is also undefined. So we say that the g composition f function has 3 that don't exist, but the last one, 5, 5, does exist, so that's the only solution that we have. Here's another composition example, but this time the functions are not ordered pairs, they're expressions. So let's see how that makes it different. So first we want to find f of g of x. Well, g of x is x squared plus x minus 1. So we're going to find f of x squared plus x minus 1, because that's what g of x is. Now in the f of x function, our x value is x plus 3. So if we want to find f of x squared plus x minus 1, we replace the x with that polynomial. And then we have a plus 3 on the end. And we simplify this. X squared plus x plus 2. That's what the composition of those two functions is. So go over here now and we'll find g of f of x. F of x is x plus 3, so really we're looking for g of x plus 3. Now in the g function, or the g of x function, we have an x squared plus an x, and in place of those we're going to put x plus 3 in both of those spots. So x plus 3 squared instead of x, and then plus x plus 3 minus 1. And now simplify. This creates a trinomial, perfect square trinomial. Drop the parentheses here. Collect like terms and write in descending order. Now in this last example, we want to take the compositions that we just found and we want to evaluate them for a certain value. So I'm going to start by writing down that the composition of functions this way on the previous video was x squared plus x plus 2. And the composition of functions g of f was x squared plus 7x plus 11. So these are the composition of functions I found on the last video, and now I'm going to evaluate those for x equals 2. So I'm going to replace the x with all 2's. 2 squared plus 2 plus 2, 4, 6, 8. So the composition is 8. When I plug a 2 in, and then likewise over here, Plug a 2 in for all the x's. 2 squared, 7 times 2 plus 11. 4, 14, that's 18 plus 11, 29.